On, yes, I'm not as tall as everybody else. All right. So yeah, today we're going to spend the next 25 minutes or so talking about new and old ways for managing grape powdery mildew. So really, the premise behind this talk is one, to mention some of the projects we're working on that has been funded by you guys through this state leader tax, but also to kind of provide a background on ways we can reimagine some of our older approaches, or even incorporate modern approaches to really reduce our loss of disease control related to powdery mildew and potentially reduce environmental impact associated with the management of powdery mildew. So it's really, we already know what to do, but can we do those things better or more efficiently? And so we'll go back to here. The three major areas we're going to talk about today are the use of UVC or germicidal light as a non-chemical intervention strategy for powdery mildew management, rethinking the use of sulfur, so a modern approach for a very old means of powdery mildew management. And then I'm going to say the dirty 5-letter word hybrid, or what I like to say modern varieties, and talk about what their role might be in sustainable disease management. So first, let's talk about UVC light. So as you guys know, grapevine powdery mildew is a fungus that really grows on the external part of the plant. So it's very, very exposed to environmental conditions. And we often use that to our advantage, right? So it's the reason why we often don't have to spray as early in the season, because it's quite cold. So it suffers from exposure to cold temperatures. And then by midsummer, we get quite hot. So the fungus suffers from heat exposure as well. So we have a nice compact time period for which we manage disease. And because that fungus is highly exposed to environmental conditions, we can potentially manipulate that. UVC light is a form of UV light that does not naturally reach the Earth's surface. We get UVA and UVB, but UVC is screened out in our upper atmosphere. And UVC light, just similar to other UV light wavelengths, can damage DNA. So just like we can get skin cancer from sun exposure, that same type of damage can happen to any type of fungi or other organism when it's exposed to light. This is my nice little graphic of sunlight and powdery mildew. I used ChatGPT to generate that. And as you can tell, for students who are using ChatGPT, always double check your work because it doesn't understand a lot of scientific concepts, such as fungi. So here it thinks powdery mildew, botrytis, aspergillus, and penicillin are all the same thing. So there you go. There's your mutant fungus. So UVC light is actually a very old tool for disease management and honestly use of management of other viruses and things, as we saw during COVID. And in vineyards, and specifically, people started using UVC light for disease control back in the 1990s. But it was literally tanning beds mounted to the side of tractors, but that resulted in extreme fruit burn. So in order to dose to provide UVC light at a dose that would actually kill powdery mildew, it would also kill the outer surface of most plant tissue. So of course, discarded as an unuseful tool, people ignored it. And then some work out of New York and Norway noticed that when you exposed powdery mildew or plants to UV light at night, suddenly low doses of UVC light worked. And they discovered a mechanism within a lot of fungi. It's called UVB, it's blue light repair of UV damage. And blue light also comes in the form of sunlight. So when you expose an organism to UVC during the day, that organism can then repair that damage. But if you expose an organism to UVC at night, there is no blue light to help repair mechanism. So that damage becomes permanent and then it kills the fungus. So that was a fantastic discovery. And then since then, there's been a lot of work on different wavelengths in the UVC spectrum that can function as germicidal effects on a lot of different fungi. So this is nothing new to us here in Washington. It's been proven by many other organizations and many other powdery mildews, cucurbits, strawberry, hops, grapes. So we know this type of approach works for powdery mildew. So what the Wine Commission has funded, or the Washington Grape Wine and Research Program funded here in Washington State, was a chance for us to maybe go a little bit deeper to figure out how we could potentially incorporate UVC light into disease management programs and what other properties the use of UVC light might impart and as a part of a disease management program. So a former graduate student, Lexi McDaniel, worked on some laboratory studies looking at when in a disease cycle we could potentially use UVC light. Could this be used as a curative or an eradicant? So or does it have to go on right as an infection starts? And then Lexi, in addition to my current student, Jesse Stevens, they're working on ways to incorporate UVC light in actual functional vineyard regimes. So whether UVC light as a standalone fungicide program, I'm going to use that in quotes because it is a fungicide, just not not necessarily a liquid sprayed one, or can it be integrated into existing management programs as almost like a fungicide rotation? And so what we found initially with Lexi's work is that UVC light is truly an eradicant. It can actually kill existing established mildew colonies, and that's a pretty powerful thing to do because not many other fungicides do that. We compared it, so there's a lot of graphs, you can read it, it's published open access on AJAV, so you don't have to like take notes here. But fundamentally at normal application doses, which is similar to your ounces per acre, if you will, it provides a nice equivalent eradicant activity relative to a high rate of stylet oil. So that's a pretty good thing. We do notice that it doesn't necessarily work on brand new infections. So if spores just land, UVC light is a little bit harder to kill those spores, probably because it's a very small surface area. But as those spores infect and then start to develop, there is more fungal surface area to absorb UVC and the damage becomes a bit more permanent. Once colonies get really established, so about 6 days, which is usually about the time that you might be able to start visibly seeing it, you still get damage to those colonies if they're exposed to UVC, but it's not as permanent as if you expose them when they're younger. So that's a nice thing. That means this particular technique can be used early to mid-season to help either help it clean up essentially existing infections in the vineyard. Infections you cannot see, though. I would like to emphasize that. 3-day colonies you cannot see. So there's kind of post-rain events, and then you can spray, or then you can use UVC light. And then the follow-up to that was trying to see how we can incorporate this in typical vineyard programs. And so this upper row, again, all this is published, and we have posters on this as well. So if you can't see the little graph here, you can go look at it in a nice, much larger format during the poster session. So my student Lexi worked on just UVC in vineyard, so UVC only, no additional fungicides. She did so for 3 years from 2020. So you can imagine that was a tough year start for a graduate student when the university was entirely shut down and we were trying to deploy some field work. And in 2021, when we had temperatures well over 100 degrees Fahrenheit during the entirety of bloom and post-fruit sets, we had no disease to compare anything to. So that was for Lexi. And then she was wondering if she was ever going to graduate. And then finally in 2022, we had a semi-decent disease from a research perspective to evaluate the program. And so again, her work was entirely, can we use UVC light totally in the absence of fungicides? And the answer is you can. It's not as effective as a full fungicide program when you just use UVC light, but it does do better than doing nothing at all. So with that information, we're like, okay, so UVC light from a risk perspective is not something you can entirely replace in a program, but maybe we can incorporate it to reduce overall fungicide inputs. And that's what my student Jesse Stevens is currently working on, where we're looking at incorporating UVC during the critical window. So from pre-bloom to about 3 to 4 weeks post-fruit set, we start the season off with a sulfur spray or 2. We use UVC light, and then we have maybe 1 or 2 synthetic fungicides at the end of the season, depending on the length of the season and depending on if it's a botrytis type year or not. And we have found that the use of UVC light either once a week or twice a week during that critical window is just as efficacious as using a full fungicide program. It doesn't eliminate the number of tractor passes, but it does eliminate the number of actual fungicide sprays by about 3 or 4. So that's a nice effect. He has also worked on, because it's light, the idea is maybe we need more open canopies for this to be more efficacious. He has worked on looking at different canopy management strategies, shoot thinning plus leaf removal, and really UVC light in that integrated program that you don't necessarily need to do additional canopy management to achieve good results. The only time that canopy management actually helped is when we did nothing at all. So if you choose to never spray your vineyard, then you should be doing canopy management. But if you have efficacious programs, you don't necessarily need it for this particular approach. So it's not one of those that by adopting UVC, you then also have to adopt all these additional cultural practices. You can very easily integrate it into what you're already doing. All right, next, sulfur. Love talking about sulfur. So as we know, sulfur is a very old fungicide for the control of a grapevine powdery mildew. And to be frank, it was at one point considered a miracle drug for controlling grapevine diseases because it was one of the first things discovered that could actually manage grapevine powdery mildew. But with that, of course, when we discover, is most common with human nature, when we discover something that's a miracle drug, if a little bit's a miracle, then a lot's an even better miracle, right? And I think over the years, we've adopted an approach where we're using a lot of sulfur and we probably don't need to. And And then we realized that synthetic chemistries came on the market in the 1960s and 70s, and we backed massively away from sulfur and have actually indicated or have told ourselves that sulfur is bad. But that's probably not true either, right? Humans tend to pendulum swing. And so really some of the original work coming out of sulfur use out of California, which I love reading some of the old extension articles because the language is quite colorful. So I highly recommend reading those. But some of the original recommendations were you want to spray the canopy so there's a light coating of sulfur so that none of the fungus can escape the death rays. He didn't say death rays, that's my word, but the death of sulfur. So it's quite, so the intentional recommendations were from bud break to almost pre-harvest, sulfur, 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 sulfur. And originally that was 30 to 40 pounds of dusting sulfur at a very low purity rate about every 7 to 14 days. Right? That is a lot of sulfur. That's an excessive amount of sulfur. And then of course, modern chemistries came up, and of course with excessive sulfur, it's a chaotic system. And when you take away the chaos of disease one place, you're going to add chaos elsewhere. So of course, with this excessive sulfur, we started seeing mite flare-ups, right? We started seeing issues with fermentation, SO2 production. And of course, when we started growing grapes in more humid climates, and also hybrid varieties, French American hybrids in the Northeast, we started seeing sulfur phytotoxicity, right? So these were all then reasons to not use sulfur, stop using sulfur. And then why don't you purchase these fantastic synthetic chemistries that you only have to spray every 14 days? And they are a cure-all for everything. And it's absolutely fantastic, and which we did. And that worked well for us until it's no longer working for us, right? So we have fungicide resistance to a lot of those chemistries. A lot of the formulations of those chemistries, such as emulsifiable concentrates, also cause phytotoxicity when sprayed in the heat of the day. We're mixing a lot of things in the tank, foliar nutrients, adjuvants, insecticides, fungicides, to the point where that's probably too much chemistry in a single tank to spray. And we're starting to have problems with those approaches today. And so when we start thinking about sulfur, I really want us to consider some of the modern components with sulfur. One, we use very different formulations now. We're using micronized and wettable and flowable sulfurs. So these go into solution better. They're also smaller particles, so are a bit more efficacious, so you don't have to use as much. Our use rates are not 30 to 40 pounds per acre anymore, right? And I think in many cases, some of us are down to 2 to 3 pounds per acre. Our yeast, and so that kind of solves that kind of mite flare-up issues. If you do a low enough dose, you might be able to stay below thresholds that are problematic. Yeast genetics are different. We use different yeasts. And also we're not spraying that late into the growing season. So SO2 generation as a result of actual vineyard particulate sulfur is probably pretty low. You will still see reports on the East Coast, but they also spray a lot more than we do, 15 times a season versus 8. So we want to keep those kind of management things in our context. Also, we're growing grapes in a very dry climate, right? Very low humidity. And I think when we start talking about phytotoxicity on some of these products like sulfur, like copper, we'll see that humidity plays a major role in whether that phytotoxicity is expressed. And the understanding of what drives product selection, right? So oftentimes trends in what we use are based on marketing trends. And for a number of decades, marketing trends were on these synthetic chemistries. And of course, people will say and market what they need to get you to transition over. And so perhaps we took that bait, and that's okay, but maybe it's a chance to rethink other products. So that's a study that my current student, Jesse Stevens, is working on here in Washington. I wanted to ask the question of what causes, so what I've heard out here is we don't want to use sulfur mid-season, so July-ish or so, because we're worried about heat-based phytotoxicity. And Mary Ortalic is going to be talking to us later today, and I did spend some time in Loxton, South Australia, so also very hot. And I noticed down there, especially relative to where I was earlier in Cornell, in New York, they were spraying sulfur at much higher temperatures than we were in New York, and they were not seeing as much phytotoxicity. So that starts to bring up questions. In very hot climates, sulfur is often used much later in the season without this scare, the fear of phytotoxicity. So Jesse is working on a number of questions. We're asking sulfur rate, low rates, high rates of sulfur, what might cause phytotoxicity. We're talking about what adjuvants you're mixing in with that sulfur, because we all know when you start mixing things with other things, chemistry happens. And then also weather conditions, spraying during high heat or high humidity, different types of environmental combinations that might impact the expression of phytotoxicity. And we're doing these in both field studies, potted vine studies, and growth chamber studies. So these studies still are currently ongoing. So I'm only going to show you some initial results from that, but I just wanted to say that this is what we're currently working on. And so I'll let you know, we sprayed a lot of sulfur on very hot. So Jesse's in the back right there. You can see, like, he about melted. We put him up in Tyvek suits and made him spray. And in mornings where temperatures would often exceed 90 to 100 degrees during the day, we sprayed a lot of sulfur at very high rates. And yes, I did mix sulfur with JMS stylet oil as an adjuvant, very low rates, 0.5% volume by volume. And do you think we got burn in our vineyard in July? I see some heads shaking no, and you are correct. We did not get any burn. And this is a fantastic, visualization. Also very bad for Jesse, because in order for us to do studies on burn, I have to be able to get burn to replicate it. And so we're like, Jesse, up that rate, add more oil, spray when it's hotter, but you have to stop at a certain point. So the following season, we made him do some potted vine studies because I could make him do more when vines are small and contained. And same thing, we saw very, very minimal burn. And typically we only saw that with very specific adjuvants. In this case, the product was called Embrace, which is an adjuvant that's typically recommended at much higher volume by volume rates. So that's probably just a concentration based. And we really only saw it on sprays that had our it wasn't our highest temperature, but it had our highest relative humidity at the time of that spray. So move to our indoor trials where Jesse can actually control temperature and humidity. And same thing, what we see there is typically we only see burn related to any kind of product, whether it's sulfur or just adjuvant. When the leaves are young, that's what one would expect. Young tissue tends to be a little more succulent. And really only when we see a high relative humidity for extended periods of time. So we have to have, in these cases, Jesse would only see burn on plants that were exposed to relative humidities at about, it was at 80%, Jesse, 80% for 8 or more hours at a constant temperature. So that's a pretty big, and again, it was with very specific sulfur and adjuvant combinations. So we still need to do more work on that before I have a final recommendation for you. But I do feel that we're starting to see that we may need to step back and say, is sulfur really, especially low rates of sulfur, really that bad? Kind of that June and July period, especially when we need it most for managing fungicide resistance for those that are still choosing to use synthetic high-risk products. That's interesting. All right, now my final one, which is my soapbox that I'm going to stand on for the last 10 or 15 minutes, is modern grape varieties. So this is me talking about rootstocks 10 years ago when you guys said, no, we do not want you to talk about rootstocks, Michelle. We don't like rootstocks. I'm just saying at some point it might be something we have to think about and to embrace. And so my alternative to this title or to this particular section is that while I love talking about grapevine powdery mildew, I've done so for about 20 years and I would really like to stop. And this way, if you guys would help me stop talking about powdery mildew, modern varieties is going to be a part of that, getting me to stop talking. So just, you really don't want to hear me anymore, definitely start planting these and then we'll never have to talk again. And that's great. Well, we'll talk about other things. Right, Kate?
Yes.
Nutrition, other things, more fun things. So the real question is, if Vitis vinifera is so awesome and versatile, why change? This is my favorite picture ever, right? See it, Bob? See the joke there, right? So it's versatile, it's perfect. We do a lot of great things with it. It's not broken. We can market it, but I would say vinifera is kind of broken, right? For many reasons, we'll ignore marketing aside. For many reasons, vinifera, while it has fantastic winemaking properties, it's kind of an obnoxious thing to grow from a vineyard perspective. It is highly susceptible to most of it's really the variety that we grow and what we have to spray things for. So if you want to really think about sustainability and reduce pesticide inputs, the first step is to grow something that doesn't require them in the first place, right? So I'd like to toss that out. Vinifera is adapted to very specific locations and it's susceptible. So we have to keep that in mind. Modern varieties, so these are new varieties. These are not genetically modified varieties. They are just modern selected varieties. Really have an opportunity to allow us to expand viticulture into regions that perhaps we haven't grown grapes in before. And we can maybe view that as a positive or negative thing. That's more of a political discussion. But more importantly, it can really help reduce our reliance on pesticides, where we can do low input vineyard production and maybe from a chemical perspective, and maybe get to spend more time doing the great viticulture things that we love to do, such as canopy management, nutrition management, right? And so I think that the challenge when I say modern grapevine varieties is a lot of us in our minds have had a chance to try the not modern, well, they're actually still technically modern, but some of the older hybrid varieties that are out there. And so some of these original varieties were bred to combat powdery mildew, right? So they are powdery mildew disease resistant. Some of them are bred to combat foliar phylloxera or root-borne phylloxera. And so I would like to point that out. A lot of hybrid or modern varieties are phylloxera resistant on their own roots, which I know is something we often talk about when we talk about the adoption of rootstocks for phylloxera management in Washington State with the concern of having a grafted vine. Modern varieties may eliminate that concern because it'd be going back to own rooted, except in this case, the own root has some phylloxera resistance. A lot of these early plantings were in parts, especially in the United States, were in parts of the country that absolutely needed them, of course, but also in areas that perhaps didn't have a mature winemaking industry. So we didn't necessarily have individuals who knew how to use these varieties to the best of their ability. And that, of course, combines, and they have very different chemical properties, right? So those combined probably resulted in some subpar wines, of which we developed our, I will say, preconceived notions on what a hybrid wine can potentially be. And there are a lot of great breeding programs that exist in the United States that have, since some of these original introductions, are still working on varieties that are locally adapted to those areas. The thing is those old varieties were bred in very, very traditional methods. It would take 30 to 40 years to release a grapevine variety. And you never really quite knew what was going to happen in the fruit, right? Because you just had to wait and then grow the grape and then harvest it and then make wine. And if you've ever done a breeding program, you start off with hundreds of thousands of seeds. And in maybe 40 years, one of those little seedlings will be the variety that you release. It's a very, very slow process. So in the last 20 to 30 years, closer to the last 20, with the sequencing of the grape genome, breeding can happen faster. It is not genetic modification, but it's essentially like a DNA barcode where you can take some DNA from little seedlings and say, does this particular seedling carry these traits for fruit quality, for color, for disease resistance that I want? So you can screen much faster. And so with this, we've developed this whole technical term, technical tools associated with grape breeding, because we started with this grape genome, which is like this unorganized encyclopedia of genes that we have no idea what each things do. We've done mapping called quantitative trait, or what we refer to as quantitative trait loci or qualitative trait loci. So we know we've bookmarked the encyclopedia for the pages that we really like. And then with marker-assisted selection and breeding, we know exactly, we've now digitized that bookmarked encyclopedia and we can type in a specific search function and get the information we absolutely need. There's really spread up breeding processes. But even with that, breeding modern varieties takes a long time, right? This whole marker-assisted selection and rapid breeding really speeds up that initial selection. And that's a pretty big deal because you have to get through that in order to plant something to then subsequently make wine and evaluate how they work. So even with modern varieties, it can still take 20 to 30 years to release a variety. And the reason why I'm saying that is by the time some of these new varieties are released to you and they're on the market, they have been grown for 20 years. They have a lot of data associated, at least with vineyard production, just perhaps not necessarily winemaking production because they're not grown at a scale that we can try it in different environments and with different winemaking techniques. So even modern varieties, they take a long time and a lot of vetting to get to you. So they have been fairly well vetted by the time they're released onto the market. I mean, it took us thousands of years to figure out where we want to grow different vinifera varieties, and yet we're concerned about a new variety that's only been around for 30 years. Well, I don't know, we need more data. Well, in 1,000 years, they won't need that data, but I think we want to speed up on that a little bit for our purposes. So with that, I think one of the comments too that I get from folks when we start talking about modern varieties is there will be no consumer market recognition of these names. So I would like you to, I'm not going to ask you to raise your hand. Well, maybe I should ask you to raise your hand. So below or and those who are in the hort or viticulture and enology senior capstone class, you're not allowed to answer these questions. Or 490 in Thomas's class because they've already seen this slide. But I want you to step back and think, and some of you guys already know. On this slide, there are some modern varieties and there are some very, very old vinifera varieties. Ask yourself, just by looking at the fruit or the name, if the idea that name recognition is super important, if you can tell which is which. You can. Anybody want to guess? Raise a hand. Is Floreal a hybrid or a old variety? Or I have no idea. You can raise your hand. So who would say I have no idea? I don't even want to guess. Good. How many want to say it's a hybrid? How many want to say it's an old variety? It is a hybrid. All right. Periada. Old variety, hybrid. Who says I have no idea? Which is a good question because I actually had to dig for this one too. Who says it's a hybrid? Well, who says it's an old variety? It is a very old variety. Super hot in Napa right now because everybody wants to plant unknown varieties, which is interesting because we're willing to plant unknown vinifera, but not unknown modern. All right, Friano. Well, this one I shouldn't ask. You guys are growing some of this. So guys, that's an old vinifera variety. And then Caminante Blanc, is that vinifera? Raise your hand if you think it's vinifera. Raise your hand if you think it's a variety or a hybrid. Raise your hand if you're like, I have no idea. It is one of Walker's new Pierce's disease-resistant variety out of California. So what's in a name, right? Just things to think about when we start asking ourselves these questions. So really, that I'm almost done. I think Melissa told me to leave 5 minutes for questions, and I don't know where Melissa is, but I think I'm on time. Really, I want to kind of end this very rapid fire discussion on that, on powdery mildew management, and that having options and flexibility in how we do things is pretty critical for the future of farming. Whether that's knowing how to better use our existing tools, knowing how to integrate some new technology, or maybe even having kind of longer term, bigger discussions on the use of different varieties when that time arises that we can start rethinking planting problems. And that does require a mindset shift, right? When we plan for the future, plan for future generations, farm for future generations, it's not about what pencils out right now, but it's what pencils out this year, in 10 years, and in 50 years, right? And really, let's maybe have a deeper discussions on what might be possible rather than what has historically worked, right? Because a lot of things have historically worked, but sometimes history isn't always what we want to do, right? So with that, I do want to thank my current and former research team, all the funding we've received for this, our vineyard that we butcher every year with heavy powdery mildew research. And with that, I think I can take a whole couple questions, Melissa.
So if we wanted to get our hands on planting some of these new varietals, what's the best way to kind of look up their profile, their climate that they prefer, all that good stuff, and then follow up to that, where can we get them in any kind of quantity to plant?
So these are fantastic questions. So I'll start with the second part first. Where can I get them? So a lot of these varieties are proprietary, correct? So they are through various marketing agreements. And of course, in Washington State, we have quarantines and blah, blah, blah. So we all know that to be true. So the first step is to check Clean Plant Center Northwest. And you have to select the variety first, we'll answer that the first part of your question. But once you know what you're potentially looking for, look through the Clean Plant Center Northwest list of varieties that have been introduced through there, and then Foundation Plant Services out of California. Because if they are there, then they will likely be available through a certified nursery on the Pacific Coast, right? That you can then bring into the US. I will say that the problem with modern variety is this: nurseries are supply and demand. They're not going to create and propagate and do whatever for things that don't have demand. So it is hard getting them at this point. I will say, because I'm trying to plant out Itasca and Floreal and all those in my research block, and I too am backlisted on orders because darn British Columbia keeps planting those cold hardy hybrids. So, but that's a good thing. We like that. That's a great thing. Great thing for them. So it does take time. So this is not the typical that Washington has done. Everybody who's planted rootstock now understands the slow process of this, but it's a multi-year planning process. How they perform, a lot of those, honestly, general Google searches happen, but if I can provide lists, and actually I can do that if Melissa has email addresses for everybody on our wine.wcu.edu website. I can do that for you guys on our vineyard management establishment page. I can do a section called Modern Varieties and link you to the breeding programs that produce these. The question on where they grow best, in order to answer that question, you need 1,000 years of vinifera production across multiple continents, right? So that they're going to have information on how they've performed in the environments in which they've tested. So you will have to extrapolate. That is the challenge as we start to move forward to adopting new things, right? They are unknown. So that is an unknown.
Thank you.
Go ahead.
Did you notice when you used in the UVC trials, did you notice any or observe any attenuating or effect from sprays along with that, or any sensitization? There are a lot of sensitizing agents for UV, so I'm kind of curious.
Right. So the way we did our trials, it was spray, then just UVC, then spray. So we didn't actually. So I guess is your question of, did we spray something and then UVC like denature the product kind of thing? Is that the question? Sorry, I probably should have clarified first.
Well, if you did spray and you use UVC, that's the first question. But if so, did you observe or any attenuation or?
So the answer is no, we didn't observe because we didn't have that opportunity in this particular trial. But the question of whether you were to say spray a synthetic chemistry that would stay only on the surface of the plant and then use of UVC denature that particular chemistry so it's no longer active, that would have to be a pretty tight program, right? So and most of the products that are UV sensitive are also tend to be absorbed or locally systemic. So as long as you give it enough time, which is 24 to 48 hours, you should be okay with that. But if you are going to spray and then it rains and you immediately go out with UVC, then yes, anything that's left could be denatured if it's sensitive to denaturing.
I'm particularly interested in the other way around, where it would increase the sensitivity of a particular.
Oh, so yeah.
By application of UVC along with it.
Sensitivity of the plant to the fungicide or the pathogen.
Yeah, the fungicide to the powder mildew.
So yeah, no, I probably not in that case, because they behave in very different ways. One, it's not increasing sensitivity or not. It just is, can the fungus replicate because its DNA has been damaged? So it doesn't necessarily increase sensitivity, except in the case of a potential, so this is theory, right? If you're using a contact product like follow-up oil, sulfur, bicarbonate, et cetera, where some of those, there is a dose dependency on whether existing mildew can be eradicated at that stage, that might help where you're hitting it with one hammer and then you're hitting it again. Yeah. Take that question.
Would you say a lot of the varieties that were developed, say Cornell or Minnesota, Florida, were developed to be adaptive to the growing conditions of those areas?
Right. So yeah, local breeding programs breed for local needs. Absolutely.
So,
And we don't have a local breeding program. One would argue whether or not we have a lot of conditions that would warrant a different breeding program because we deal with cold challenges in Minnesota or New York, but also, actually, I wouldn't say we have no pest. We're not breeding for the same pest and disease problems that the UC Davis program is breeding for. But yeah, so there is that question, but it's a very hard market to break into. We're not different enough, right? If that makes sense, to probably warrant an entire breeding program for these. But that is a challenge, right? So when you start selecting northern grape varieties, we do have to be a little careful about those because they're dealing with a much shorter growing season. So they tend to break bud pretty early, at least in those conditions.
and we probably don't have a breeding program here. We don't have the challenges that they have in a lot of those areas. And
They
at
would
least
laugh.
now they're looking at wine quality,
Correct.
and they didn't do that before.
Well,
early
you
on.
couldn't before, right? You can screen for disease resistance pretty early on in a breeding program, but wine quality took 10 years. I mean, Thomas knows, he's worked on with a lot of these. It takes a very long time to grow enough to get the plants mature enough to actually make wine from them. Where powdery mildew, you can screen in year 2, right? So the screening happens a lot faster.
I'm on the bandwagon with you, but I think it has to be done right.
And one in the back, and I think we're done. Okay.
Hi, Michelle. You know, I
Okay.
follow Dave Jent's work on hops pretty regularly. And, you know, his thing is about once a variety, a variety is purported to be powdery mildew resistant, then it gets planted in large acreage and the disease just adapts. And, how robust do you think long-term would these varieties maintain their resistance to powdery?
The Doug asks a great question on how do you maintain, just like with fungicide rotation, how do you maintain the efficacy of disease resistance in these varieties? Because mildew can break resistance, absolutely. So some of the varieties, I know Cornell had this when they would breed and there would be only one resistance gene. If you never sprayed the variety, it would break in about 5 to 6 years under really heavy disease pressure. We're not as heavy as New York, right? So none of these varieties are released as no spray. They're released as limited spray. So 1 spray during bloom, right? Or 2 sprays during bloom. That's versus their 15 normal regime. However, a lot of these very new varieties don't have 1 resistance gene. They're often stacked with 2 to 3 to 4 resistance genes. And that takes a lot longer for a pathogen to overcome all of those in the development cycle. So that they're building that in to the actual breeding profile of these varieties. Knowing that if I say, okay, it's a disease resistant, but you should spray once, you're like, yeah, maybe not this year. Maybe next year I'll get it. Because knowing that folks will stretch that a little bit.